Namaste and welcome to the deep dive. Today we're setting off on, well, a really extraordinary journey. Not by train, not by plane, but by tracing the very lifeblood of India, its rivers. Forget just dry facts and figures. We're going to unravel the epic sagas woven from water, land, and people. We want to discover the secrets these ancient waterways hold, maybe even for you.
Indeed. And what makes this particular deep dive, I think, quite special is that we're not just listing names and links, we're trying to connect the dots, almost like piecing together an ancient, intricate mosaic to really reveal how India's complex river systems have shaped its geography, its culture, even its destiny. Our mission really is to transform this knowledge, these facts, into a truly captivating narrative, something that sparks your curiosity.
Absolutely. So get ready as we plunge right into the heart of India's drainage systems, its majestic rivers, its serene lakes. You'll hear stories of, well, creation, maybe some conflict, and definitely conservation. Tales that resonate far beyond just the riverbanks. Okay, so to begin this grand story, maybe let's talk about the basics. How India's water actually flows. When we talk about a drainage system, what are we really looking at?
Well, fundamentally, it's the entire network. All the streams, the rivers, the tributaries,
Yeah.
everything that collects water from a particular area. And the drainage basin itself, that's the whole area, the land area, that's drained by that single river system. You can think of it perhaps like a giant natural funnel, where every single drop of rain that falls eventually finds its way to one main river channel.
Like a funnel, okay. So rain falls on a mountain, and depending on which side it lands.
Exactly. Depending on which side of the peak or the upland it lands, it will join one river system or a completely different one. And that elevated area, that ridge or mountain doing the separating, that's what we call a water divide. It's a silent separator.
A silent separator, I like that. So these divides are pretty important in India then.
Oh, absolutely crucial, particularly the broad relief features, the major mountains and plateaus. They split our rivers into two main, very distinct families. The mighty Himalayan rivers born in the north, and the ancient peninsular rivers of the south. And this fundamental division, it really sets the stage for their incredibly different stories. It's key.
Right. So two big families. Let's start with the first one then. Our first major chapter takes us high up into the Himalayas. Rivers born from ice, from myth almost. What makes them so unique? I think you mentioned they're perennial.
That's a defining characteristic, yes. Perennial means they have water flowing in them all year round, which is quite different from many rivers that might, dry up or become trickles in the dry season.
Okay, but how do they manage that even when it hasn't rained for months?
Well, they have a kind of dual lifeline, a two-pronged source. First, there's the rain, especially the heavy monsoon rains that drench the northern plains and the Himalayan foothills. That's a huge input. But second, this is critical for the dry season, they get water from melted snow and glaciers. The high Himalayas act like massive frozen reservoirs. This constant supply from both rain and meltwater gives them that immense power and that enduring year-round flow.
That makes sense. Rain and snow melt. And here's something really fascinating I read. Two of the biggest Himalayan rivers, the Indus and the Brahmaputra, they don't actually start in the main Indian Himalayas.
That's absolutely right. It's quite mind-boggling. They originate north of the main Himalayan ranges up on the Tibetan Plateau.
Yeah.
So they undertake this incredible long-distance journey before they even enter India's borders. Talk about a dramatic entrance later on.
Wow. And you can see their power in the landscape, right? These deep valleys, gorges.
Precisely. Gorgeous. These rivers haven't just flowed over the land. They've actively carved their way through formidable mountain ranges over millions of years. They cut down, creating these deep, steep-sided valleys. These gorges are just, well, they're powerful visual testaments to the sheer relentless force of flowing water.
Amazing. And then when they come down from the mountains onto the plains, they slow down, don't they? And they start creating different features.
Exactly. The energy changes. As they slow down on the gentler slopes of the plains, they start to meander. They form those lazy looping curves we call meanders. It's a much gentler process.
Right, those S shapes you see from above.
Yes, and sometimes the river finds a shortcut, cutting across the neck of a meander loop. The old loop gets cut off, abandoned by the main flow, and it forms a crescent-shaped lake. It's an oxbow lake.
An oxbow lake. Okay, and then right at the end of their journey, deltas.
Deltas, yes. As the river approaches the sea, its velocity drops dramatically. It can no longer carry all the sediment it's been transporting. So it deposits this load sand, silt, clay, which builds up over time, fanning out to form a triangular, fertile landform called a delta.
Got it. Now, just for perspective, Are India's river basins the biggest in the world?
Ah, good question for scale. Well, India's rivers like the Ganga and Indus have huge basins. They're not the world's largest. That title belongs to the mighty Amazon River in South America. Its drainage basin is just on another scale altogether. It really puts the sheer power and geographical reach of these global river systems into an incredible perspective.
The Amazon, okay, good comparison. So let's get back to the Himalayas. You mentioned three main rivers there.
Yes, the big three of the Himalayan system are the Indus, the Ganga, and the Brahmaputra. Each has a truly unique story, a distinct personality, you could say.
All right, let's follow the first one. Where does the story of the Indus begin?
The Indus saga starts way up high, in the remote arid plains of Tibet, quite near the sacred Lake Mansarovar, a very auspicious beginning.
Lake Mansarovar. And then it flows into India. Where does it make its entrance?
It makes a rather dramatic entrance into India through Ladakh. Imagine that journey, from the Tibetan plateau into the stark, stunning, high-altitude desert landscapes of Ladakh.
Incredible. And once it's in India, does it pick up more water
Go-
from tributaries?
Oh, yes. As it flows through the Kashmir region, specifically Ladakh initially, it's joined by several important tributaries. Rivers like the Zaskar, the Nubra, the Shyok, and the Hunza. They all add their waters, contributing to its growing volume as it carves its path westwards.
This river sounds massive. How long is it, roughly?
It's truly monumental. The total length is approximately 2,900 kilometers. A very long river indeed.
2,900 kilometers. Wow. And because it flows through different countries, sharing the water must be a big deal.
A huge deal. That's the critical geopolitical aspect. You
Wow.
see, it's a surprising fact, but less than 10% of the entire Indus Basin actually lies within India's territory. Most of it is in Pakistan.
Only 10%, really.
Yes, and that's precisely why the Indus Water Treaty, signed way back in 1960 between India and Pakistan, is so incredibly significant. It's considered a landmark example of international cooperation over shared, vital water resources. Under the treaty, India is allocated the use of only about 20% of the total water carried by the entire Indus River system, the Indus itself, and its main tributaries.
Only 20%. That's fascinating. So just tracing its path again, it flows through Ladakh.
Yes, through Ladakh, then it flows through Gilgit-Baltistan, and then it enters Pakistan, eventually reaching the Arabian Sea near Karachi, a truly transboundary marvel.
Okay, that's the Indus. Now let's shift our gaze to perhaps India's most iconic river, the Ganga.
Ah, the Ganga. Yes, more than just a river, isn't it? It's deeply woven into the cultural and spiritual fabric of India, a lifeline in every sense.
So where does its journey begin? Not in Tibet this time.
No, its origins are firmly within the Indian Himalayas. Its headwaters, the source stream, is known as the Bhagirathi, and it emerges from the Gangotri Glacier, high up in Uttarakhand, a truly pristine, powerful, icy beginning.
The Bhagirathi from the Gangotri Glacier.
Got it.
Does it become the Ganga straight away?
Not quite yet. The Bhagirathi flows down, and then it meets another major Himalayan river, the Alaknanda. They join at a very sacred confluence point called Devaprayag, also in Uttarakhand. It's at Devaprayag, this sacred union, that the river is officially recognized and named as the Ganga. It's quite a moment, geographically and spiritually.
Devaprayag, okay. And then it leaves the mountains.
Yes, from the mountains, the Ganga makes its grand debut onto the vast North Indian plains at the holy city of Haridwar. This is a major transition point. Its character completely changes. It slows down, widens, becomes the broad, fertile, life-sustaining river that millions depend upon.
And like the Indus, it must collect water from many tributaries.
Oh, absolutely. The Ganga is a master collector. It gathers water from major Himalayan tributaries coming from the north, like the Yamuna, and the Yamuna itself has a major origin, the Yamunotri Glacier. Then there's the Gagara, the Gandak, the Kosi, all big rivers in their own right. And importantly, it also receives water from rivers flowing northwards from the peninsular uplands like the Chambal, the Betwa, and the Sun. So it draws water from both sides.
A huge gathering of waters. Now, I read something about it splitting in West Bengal.
That's right, a fascinating feature. As the Ganga flows further east into West Bengal, it reaches a point called Faraka. There it bifurcates. It splits into two branches. One branch, the Bhagirathi Hooghly, flows southwards through West Bengal, past Kolkata towards the Bay of Bengal. This is a major distributary. The main channel, however, continues flowing eastwards into Bangladesh.
Okay, so it enters Bangladesh. What happens then? Does it keep the name Ganga?
In Bangladesh, the main stream of the Ganga joins with the Brahmaputra River, which also flows into Bangladesh from India. This combined, immense river then takes on a new name, the Meghna. So the Ganga's identity merges into this even larger river system before finally emptying into the Bay of Bengal. It highlights the interconnectedness across borders.
The Meghna, wow. And all this water joining together, that leads to the delta, right? The Sundarbans.
Precisely. The Ganga, along with the Brahmaputra and Meghna, forms the enormous Sundarban Delta, the largest delta in the world. It's a vast, incredibly rich and unique ecosystem. And its name comes from the Sundari tree, which thrives in these mangrove
With
forests.
the Sundari tree, okay. And it's not just the biggest delta.
Now, it's also one of the fastest growing deltas globally. It's a constantly changing, dynamic landscape. And of course, it's famously home to the magnificent Royal Bengal tiger, a truly special place.
Incredible. And the Ganga's total length,
Mm.
just to get a sense of its scale again.
The Ganga stretches over 2,500 kilometers. A truly immense river, a lifeline that has shaped culture, agriculture, and history across the vast Indo-Gangetic plain.
Over 2,500 kilometers.
Amazing. And just before we leave the Ganga, you mentioned water divides earlier. Is there a specific place separating the Indus and Ganga systems?
Yes, there is. The city of Ambala, located in Haryana, sits on that crucial water divide. It seems like just another city, but geographically, it's a silent but significant point. Rain falling to the west might end up in the Indus system heading to the Arabian Sea. Rain falling just slightly to the east will flow towards the Ganga system in the Bay of Bengal. A quiet town, yet a separator of two colossal river destinies.
Ambala, that's a great detail. Okay, so Indus Ganga, who's our third Himalayan giant.
Our third major player is the Brahmaputra, and its story is really one of dramatic turns, different names, shifting identities.
Sounds intriguing. Where does it start? Also near Mansarovar Lake. Yes. Remarkably, its source is also in Tibet, very close to the sources of the Indus and the Sutlej, a major Indus tributary. It rises east of Mansarovar Lake, but its path from there is completely different from the Indus.
How so? Is it longer or shorter than the Indus?
Interestingly, the Brahmaputra is actually slightly longer than the Indus overall. But, and this is key, the vast majority of its long course flows outside India, mostly through Tibet, before it even reaches our borders.
Okay, so it travels a long way before getting to India. How does it enter? You mentioned a dramatic entrance earlier.
Oh, it's incredibly dramatic. As it flows eastwards through Tibet, it reaches this towering peak called Namcha Barwa. There, the river makes an abrupt, almost unbelievable U-turn. It literally turns back on itself, and then it plunges southwards, entering India in Arunachal Pradesh by carving its way through a deep, formidable gorge. What an entrance.
A U-turn at Namcha Barwa. Wow. And once it's in Arunachal Pradesh, is it called the Brahmaputra then?
Not immediately. In Arunachal Pradesh, after entering through that gorge, it's known locally as the Dihang.
The Dihang. Okay, so when does it become the Brahmaputra?
It becomes the Brahmaputra once it flows down into the Assam Valley. There, it's joined by several major tributaries like the Dibang, the Lowit, and many others. This confluence of the Dihang and these other powerful rivers forms the mighty, wide, often braided river that we recognize as the Brahmaputra in Assam.
So it has different names. What was it called back in Tibet before the U-turn?
In Tibet, where it flows for a very long distance, it's known as the Sangpo, meaning the purifier. So Sangpo in Tibet, Dihang in Arunachal, Brahmaputra in Assam. And then it flows into Bangladesh to join the Ganga and become the Meghna, a river of many names indeed, each marking a stage of its journey.
Sangpo, Dihang, Brahmaputra. Quite a journey. But here's something I found puzzling. You mentioned it flows for ages through Tibet, but apparently it carries less water and less silt there compared to when it's in India. Why is that?
That's a very astute observation. And the reason lies in the climate and geography of Tibet. Tibet is largely a cold, high-altitude desert or semi-desert. It's quite dry, receives relatively little rainfall compared to regions like Assam. Because there's less rainfall, there's less water flowing into the river initially. And because it's cold and dry, there's also less erosion, meaning the river picks up less silt, less sediment.
Ah, okay, so the climate limits the water and the erosion.
Precisely. So the Sangpo in Tibet is a large river, but it carries a smaller volume of water and is much clearer, less silt-laden than the Brahmaputra becomes later. It's only when it descends into the heavy rainfall regions of northeast India, especially Assam, that it collects enormous amounts of water and sediment, transforming into that powerful, often flood-prone, silt-heavy river we associate with the name Brahmaputra.
That makes perfect sense. The environment shapes the river's character so much. Okay, from the icy, dramatic heights of the Himalayas, let's completely change scenery. Let's journey south to peninsular India. The rivers here have a different rhythm, right? More tied to the seasons.
Very much so. The peninsular rivers are generally rain-fed, unlike the Himalayan rivers, which also have snowmelt. Their flow fluctuates much more dramatically with the seasons, peaking during the monsoon and reducing significantly during the dry season. They tell a different story, often older geologically.
And is there a main water divide here, like the Himalayas up north?
Yes, the primary water divide in peninsular India is formed by the Western Ghats. These ancient mountains run parallel to the western coast, and they effectively dictate where most of the rainwater flows.
The Western Ghats. Okay, so which way do most of the big peninsular rivers flow?
The vast majority of the major peninsular rivers like the Mahanadi, the Godavari, the Krishna, and the Kaveri originate in or near the Western Ghats but flow eastwards. They cross the Deccan Plateau and drain into the Bay of Bengal on the eastern side of India. That eastward tilt of the peninsula is quite pronounced.
Eastwards, towards the Bay of Bengal. Okay.
Yeah.
But, there are always exceptions.
Always. And peninsular India has two very significant exceptions to this eastward flow.
I thought so. Which ones break the pattern?
There are two major long rivers that defy the trend and flow westwards from central India towards the Arabian Sea. And interestingly, because the western coast is steeper and narrower, these rivers tend to form estuaries at their mouths, rather than the large deltas typical of the east-flowing rivers.
Estuaries, not deltas.
Okay.
And these westward flowing rivers are.
The two big ones are the Narmada and the Tapi, or Tapti. Their westward journey is a fascinating geological story in itself.
The Narmada and Tapi. Let's take the Narmada first. Tell us its tale. Where does it start?
The Narmada rises in the Amarkantak Hills in Madhya Pradesh, quite centrally located. And what's really unique is its path. It flows westwards primarily within a rift valley.
A rift valley. What's that exactly?
A rift valley is basically a trough, a sunken block of land formed between two geological faults or cracks in the Earth's crust. The land is literally dropped down. So the Narmada flows along this pre-existing geological depression, which guides it towards the west. Its basin covers significant parts of Madhya Pradesh and Gujarat before it finally empties into the Arabian Sea through an estuary.
Flowing through a fault line, essentially. Wow. And the Tapi, does it do something similar?
Yes, the Tapi story is remarkably similar, geologically speaking. It runs almost parallel to the Narmada, but south of it. It rises in the Satpura Ranges, specifically in the Betul district of Madhya Pradesh. And like the Narmada, it also flows westwards in a rift valley, flanked by hills. However, the Tapi is considerably shorter in length compared to the Narmada.
Shorter, but also in a rift valley. Which states does its basin cover?
The Tapi's basin mainly covers parts of Madhya Pradesh, Gujarat, and also Maharashtra.
Okay, Narmada and Tapi, the westward exceptions. Now, back to the big eastward flowing rivers. Which one is the largest in the peninsula?
That title belongs to the Godavari. It's the largest peninsular river by far, in terms of both length and drainage basin size.
The Godavari, where does it begin its journey?
It rises from the slopes of the Western Ghats, not too far from the Arabian Sea, actually, in the Nasik district of Maharashtra, but then it flows eastwards right across the Deccan Plateau.
And its length, how does it compare to, say, the Ganga?
It's quite long, approximately 1,500 kilometers, significantly shorter than the Ganga, but still a very substantial river for the peninsula.
1,500 kilometers, that's impressive. Does it have a nickname, like the Ganga?
Yes, it does. Because of its large size and its importance to the south, the Godavari is often affectionately known as the Dakshin Ganga.
Dakshin Ganga, the Ganga of the south. That makes sense. Who else flows east? Mahanadi.
Yes, the Mahanadi is another major eastward flowing river. It rises in the highlands of Chhattisgarh. It flows for approximately 860 kilometers before forming a large delta on the Odisha coast, draining into the Bay of Bengal, vital for agriculture in that region.
860 kilometers for the Mahanadi. Okay,
Yeah.
What about the Krishna River?
The Krishna is another very significant eastward flowing river. It originates from a spring near Mahabashwar, also in the western Ghats of Maharashtra, not far from the Godavari's source. It flows for about 1,400 kilometers, making it the second largest peninsular river after the Godavari, and is crucial for irrigation and power. The famous Nagarjuna Sagar Dam, for instance, is built across the Krishna.
1,400 kilometers Mahabaleshwar, Nagarjuna Sagar. Got it. And one more major one, the Kaveri.
Yes, the Kaveri. Also rising in the western Ghats, but further south, in the Brahmagiri range in Karnataka. It flows for about 760 kilometers through Karnataka and Tamil Nadu before reaching the Bay of Bengal. Though shorter than the Godavari and Krishna, the Kaveri is immensely important, culturally and economically, especially for Tamil Nadu.
760 kilometers for the Kaveri, and I heard it has a famous waterfall.
It does indeed. The Kaveri forms India's second biggest waterfall, the spectacular Shivasamudram Falls in Karnataka. It's a really beautiful sight, especially during the monsoon season. The power generated there was historically very important too.
Shivasamundram Falls, amazing. So we've journeyed along these mighty rivers, but India also has lakes, right? Not just rivers.
Absolutely. Beyond the flowing rivers, India is dotted with numerous lakes, each with its own story, its own character. They add another dimension to the country's water resources.
Before we dive into India's lakes, you mentioned a global water fact earlier about freshwater.
Ah, yes, it's quite a sobering statistic. We know only about 3% of all the water on Earth is freshwater, suitable for drinking and agriculture. But what's really startling is that of that small 3%, almost three-quarters, nearly 75%, is locked up as ice in glaciers and ice caps.
Three-quarters is ice. Wow. That really highlights how precious the accessible freshwater in rivers and lakes actually is.
Exactly. It underscores the need for careful management of the resources we can access.
So how are lakes formed? We mentioned oxbow lakes earlier.
Yes, oxbow lakes are formed by river action, specifically meandering rivers on floodplains cutting off loops. That's one natural process. Another way, especially in coastal areas, is the formation of lagoons.
Lagoons, how do they form?
Lagoons are typically formed when sandbars or spits build up along the coast, partially enclosing a shallow body of salt water or brackish water, separating it from the main sea. Chilika Lake in Odisha is a famous example of a large lagoon.
Jalika, right. Are there other notable natural lakes in India, maybe saltwater ones inland?
Yes, a very prominent example is Sambar Lake in Rajasthan. It's a large, shallow saltwater lake in an arid region. And its water is actually used for producing salt through evaporation, a vital economic resource for the area.
Sambar Lake for salt. What about freshwater lakes? Is there a really big one?
India's largest natural freshwater lake is Wular Lake, located in the Kashmir Valley. Its origin is quite interesting. It's believed to be the result of tectonic activity, changes in the Earth's crust in that region. A beautiful and ecologically important lake.
Wooler Lake, formed by tectonic activity. But humans also create lakes, don't they, by building dams?
Absolutely. Many large reservoirs in India are essentially artificial lakes created by damming rivers. A prime example is the Guru Gobind Sagar Reservoir, formed by the Bakra Dam on the Sutlej River. This is part of the Bakra Nangal project. These reservoirs are crucial for storing water for irrigation, drinking water supply, and very importantly, for generating hydroelectric power. True engineering marvels, really.
Guru Gobind Sagar. So lakes, natural or man-made, they're not just bodies of water, they play a role in the whole system.
A hugely important, often underestimated role. Lakes are vital for regulating the flow of rivers. Think about it. During periods of heavy rainfall or rapid snowmelt, lakes can absorb and store large volumes of excess water, which helps prevent or mitigate downstream flooding. And conversely, during dry seasons, they release water more gradually, helping to maintain a more even flow in the river downstream, sustaining ecosystems and water supply. They act like natural or artificial regulators.
Natural regulators, that's a
Mhm.
great way to put it. So let's bring this all together. We've traced these rivers, looked at lakes. What does all this mean for us, for people living in India today? Why should, you listening care so deeply about these systems?
Well, it comes down to this. These rivers and lakes are, quite literally, the lifelines of the nation. There's no exaggeration there. Think about the fundamentals. Rivers provide the water essential for agriculture, which is still the backbone of the Indian economy, supporting millions of livelihoods. They're used for navigation, transporting goods in some areas, and crucially, they are harnessed for hydropower generation, a vital source of electricity. Their economic importance is just immense.
Lifelines. But lifelines can come under stress, can't they? With growing population, industries.
Precisely. That's the critical challenge we face now. The demands on our river water are increasing enormously. You have growing domestic needs from cities and towns, huge demands from agriculture for irrigation, increasing water requirements from industries, and inevitably, all this activity affects the quality of the river water. Pollution from various sources is a major, pressing concern for the health of these lifelines and the people who depend on them.
Pollution. Is there any natural capacity for rivers to clean themselves?
To some extent, yes. Rivers do have a natural capacity for self-purification through processes like dilution, sedimentation, and biological breakdown of waste. For example, it's been observed that the Ganga, if it has adequate stream flow enough water volume, can dilute and assimilate pollution loads within about 20 kilometers downstream from large cities.
20 kilometers. But that sounds like it has limits.
Absolutely. There's a definite limit. That natural assimilation capacity is easily overwhelmed when the pollution load is too high, or when the river's flow is reduced, for example, by excessive water withdrawal upstream. And sadly, in many stretches of Indian rivers, the pollution levels far exceed the river's natural ability to cope.
So nature needs help. Is that why specific cleaning programs were started?
Exactly. The scale of the problem demanded concerted action. This led to the launch of river cleaning programs. The pioneering effort was the Ganga Action Plan, or GAP, which was initiated way back in 1985. It was a landmark initiative specifically focused on cleaning the Ganga.
1985, the Ganga Action Plan. Is it expanded later?
Yes, the experience and lessons learned from GAP led to a broader approach. In 1995, the National River Conservation Plan, or NRCP, was launched. The NRCP aimed to extend the river cleaning efforts to other major rivers across the country, beyond just the Ganga.
The NRCP. And what's the main goal of this national plan?
The core objective of the NRCP is quite clear: to improve the water quality of India's major rivers, bringing them up to acceptable standards. This involves tackling pollution at its source through various measures, setting up sewage treatment plants, managing industrial effluents, controlling non-point source pollution, and promoting public awareness. It's a massive ongoing national mission to protect and restore these precious, vital water resources.
A national mission. It really puts the scale of both the resource and the challenge into perspective. Wow, what an incredible journey we've been on, really, tracing these amazing stories of India's rivers and lakes, from the mighty Indus carving through the high mountains to the sacred, life-giving Ganga, and then those unique seasonal flows of the peninsular giants like Godavari and Narmada. We've seen how they literally shape the land, how they sustain life, and now how they face these really quite serious modern challenges, challenges that demand our attention.
Indeed. It feels like we've connected the dots, doesn't it? From an icy mountain peak in Tibet all the way down to a vibrant delta meeting the sea, we haven't just looked at maps. We've tried to understand why these rivers flow where they do, why they matter so profoundly, how they're woven into India's history and culture, and how intricately our own lives, our future, are connected to their health. You're right, every drop really does tell a story.
So thinking about our listeners, what does this all mean for you? Maybe the next time you cross a bridge over a river, or see a picture of one, or even just turn on a tap, perhaps you look at it or think about it with slightly new eyes. You might remember its epic journey, its unique character, the immense forces that shaped it, and also the delicate balance it maintains, a balance we're now impacting so much. It's definitely more than just water. It's a living, flowing narrative.
And reflecting on that narrative, on the increasing pressures we discussed, the growing population, the rising demands for water, it leads to a really important question, I think. A question perhaps for you, the listener, to ponder. How can we, both collectively as a society and perhaps individually in our own choices, how can we ensure that these magnificent, vital river systems continue to thrive, not just for us, but for all the generations yet to come? How do we truly become responsible custodians of their stories and, crucially, of their future?
That's a really powerful thought to end on. How do we become custodians? Thank you so much for joining us on this deep dive into India's incredible river stories. It's been fascinating. Until next time, keep exploring, keep asking questions, and keep learning.